Welcome to today's tutorial. We are going to be doing something kind of different, but it still counts with the teaching aspect of my niche. Now we're going to be talking about how OCT work. OCT is optical coherence tomography. This test is one of the tests the glaucoma patients undergo. It's part of their investigative test, especially at the first visit to the hospital. Now, I'm someone who have worked with an ophthalmologist for 11 years and still counting. I am in a better position to tell you how this OCT works based on the teaching, the classes we've been having, because where I work, we don't only work, we do seminars, we do conferences, we do teachings. So now, stay with me on this topic. The agenda is going to be how does OCT work, their key components, and the type of OCT. Then we're looking at the principle of OCT. OCT, the principle is sending light in. You can imagine you have a flashlight that emits special light. Imagine that. In OCT, this light is sent into the object you want to examine, like your eye, what you want to examine at that time. Then the bouncing light. This spatial light bounces off different layers or structure inside that object. Some of this light reflect back from shallow parts, and while some goes deeper before bouncing back. Then another principle is the measuring time. That's the science behind the OCT. OCT measures the time it takes for the bounce back light to return. You can think of it as timing how long an echo takes to return when you shout into an empty room or in a carrion. Now, the eye as a camera, simplifying the eye structure. Cornea and lens is equal to camera lens. For refreshing our memory, cornea is the clear front part of the eye. And the eye lens you see are like the lens of the camera. The lens, the eye lies this. If you see the lens of the camera, that's the function of this your lens, the eye lens. So they focus incoming light onto the back of the eye. So if there is a light coming, the lens will focus it into the back of the eye. The iris, the aperture. For iris is the colored part of the eye. You can see this diagram. You can use it to be relating to what I'm saying. You can see the diagram there. So what it does is that it controls how much light enters the eye by adjusting its size. Then the retina, you can see the retina, the camera film or sensor. The retina at the back of the eye is similar to the film or sensor in your camera. So what it does is that it captures the focus light. That's what it does. Then let's compare OCT to photography. We are trying to draw a parallels with a familiar concept. When you compare the optical coherence tomography to photography, it's going to help you way to draw a parallel line or parallels with a familiar concept. Let's take, for instance, the image capture. In both OCT and photography, the primary goal is to capture images. Photography captures visible light, while your OCT capture cross-sectional images of tissue using near infrared light. When you talk about resolution, OCT and photography, you can say that both methods strive for high resolution. Photography aims for sharp, detailed images, whereas OCT aim for precise cross-sectional images of tissues, often used in medical imaging. When you talk about depth, OCT excel in capturing depth information. It is similar to how a 3D photograph or stereoscope image provide depth perception in photography. Then the role of light, explaining how the light helps us see inside the eye. Light plays a crucial role in helping us see inside the eye through a process called vision. In a simplified explanation of how it works, you will see that when light hits the retina, like I've earlier said, is a light sensitive layer of tissue at the back of the eye. So when light hits this retina, a special cell called photoreceptors turn this light into information. When this happens, what do you think that will take place? It interprets the information and be able to go back to the retina and interpret what you see. Then when you talk about the image acquisition, how OCT capture detailed images of the eye structure. Sending light. Imagine OCT as a spatial light that sends a beam of light into your eye. The light goes inside your eye and bounces off different layers and structure like the retina or the front surface. Then measuring the bounce, OCT has a light detector that catches the light bouncing back. It's like taking a picture of the light that comes back. OCT is a medical imaging technique that uses low coherence light to create a detailed cross-sectional images of the tissue. I mentioned this, such as the retina in the eye. So how it works, by measuring the time it takes for the light to bounce back from different layers of tissue, allowing for high resolution imaging without the need for invasive procedures. OCT is widely used in ophthalmology and other medical fields for diagnostic and monitoring. Explaining the concept of interference to measuring distances within the light, you can see it. Principle of interferometry, I mentioned it. You can look at it. The sending in light, the splitting the light, one part of the eye. You look at it, it's very, very explanatory for people who want to know more about this. Then we have what we call A scan and B scan. A scan is the depth profile, while the B scan is cross-sectional images. A scan and B scan are two functional modes in the OCT used for imaging, and each is serving a different purposes. A scan in OCT is like a graph showing how much light bounces back from different depths inside something. So you can look at it: A scan, 1D A scan, 2D B scan, 3D volumetric. Yeah, look at it very well. Components of an OCT system: understanding the elements. The light source produces light for imaging. The splits light into the two parts, which is the beam splitter. The sample arm send light into the object or tissue, while the reference arm direct light to a mirror for reference. Then description of the scanning beam movement. In OCT, think of a scanning beam movement like a flashlight scanning back and forth to take picture of something. So, if a spatial beam of light, which is descending light, is like a flashlight, it's directed at the object you want to see inside, like your eye. Then when you talk about the moving beam, inside of keeping the light in one place, we move it back and forth, just like when you move a flashlight side to see different parts of the dark room. The capturing information is as the light moves, it bounces off different parts inside the object. The sensors collect this bounce back light. You see, it will collect the bounce back light. That's what the sensor does. That's the description of the scanning beam movement. Then we went to talk about understanding how detectors capture reflected light. In simple terms, think of detectors in OCT like camera that take pictures of light bouncing back from inside something like your body and object. So here is how it works. A special light is sent into the object or tissue being studied. Then some of this light bounces back from different layers or parts inside the object. Then the detectors are like the light camera that capture the bounce back light. Then we are now explaining its features, advantages, limitation, disadvantages, and all that. The time domain OCT. The time domain OCT is a medical imaging technology that uses light to create a detailed pictures of thing below the surface like tissue in your body, and it does by bouncing light off target and measuring the time it takes for the light to come back, which help create images of what's inside. While it was one of the first type of this technology, newer versions are faster and commonly used. Time domain optical coherence tomography has several features and characteristics like high resolution, non-invasive. Then we have a time domain. We have time domain. The explanation of its features. It has comparative analysis. It has 3D imaging. It has improvement in technology. Then the advantages is high quality images. Then the non-invasive, it doesn't require surgery or cutting for you to do this test. Though the time domain OCT, the disadvantage there is that it's slower, limited depth, so equipment costs, or like that. So the image of time domain, you can see the time domain OCT. Look at it here. We have the spectral domain OCT. The spectral domain OCT is the medical imaging technique that uses light to create detailed pictures of things inside the body, like tissues or organ. The features are like high-speed imaging, is faster than time domain imaging, and it provides quicker results. We have spectral domain OCT. It's also fast, enhanced detail structure when you capture it. It has one wide application, and it's also non-invasive, like or non-invasive. This is the this is the spectral domain OCT. This is it here. The spectral domain OCT. It's quick pictures, the advantages. Still a medical imaging technology like other OCT technique uses light to create detailed images of structure within the eye. So it's often used for specific applications such as image the choroid in the eye. So it has captured quick pictures, sees deep inside the eye. Then we have the swept source OCT. Advantages: deep tissue imaging, fast imaging, less affected by emotion, wide imaging range. We are still exploring their types. Then we have the swept source OCT. This is the example here so that you can see what it looked like. So this is the last for the day, and thank you very much. I hope you got the lesson. Thank you.